talk is called "What is Astronomy?" And that's a big question. I'll answer questions in a while, though. Your questions. Yeah, I know you've all got 1,000 questions, but if you hang on for a little while and sort of remember them, then we'll do a question and answer session. I could answer questions all night, and sometimes I'm even right. Okay. What is astronomy? That's a major question. You think it's kind of a silly question, but it isn't. Astronomy, once upon a time, was a descriptive science. You could only sort of describe the stuff that's up there in the sky. You couldn't really reach up and touch it. Well, now we kind of can, in a very real sense. Now it's what we call a hard science. And not hard in like, oh, this is so hard, I'll never figure it out. I mean, there are some hard parts to it. But now we have calculators to help with all the math and computers to help with it too. And so now it's hard kind of the way that a geologist has a rock and can hit it with a hammer, or lick it and see if it tastes salty. You can do things that you couldn't do before. But here's what a science is, okay? An organized, systematic method for acquiring and refining knowledge. The important part is that word method right there. Okay? That's what science is. Science is a method. Science isn't a great big old dusty book. Oh no, that's not. That's information, but science is the way you get the information to go into the book. It really does. It's talcum powder. It's actually kind of nice smelling dust. I'm going to keep you on your toes. Okay.
It does smell like baby powder.
Okay. Okay. Astronomy versus astrology. Now, a lot of times if I go to a party or something, and someone will see the telescope on my hat, and then they'll say, "Oh, how wonderful! You're an astrologer." And that's at the point where I go, "Oh, no." Okay. No. So the question is, what's the difference? Because they look a lot alike. They both start with astro, and they both end in the letter Y. I mean, there's a lot of similarity there. What's the difference? Well, astrology is based on a belief or notion. And beliefs are okay, but you could also say, I believe there's no backside of the moon because I've never seen it. And, well, okay, you can believe that if you want to, but there actually is a backside of the moon. People have been there and flown over it and looked at it. Astronomy, though, is based on something called the scientific method. We got to work on our nomenclature, our naming things. Okay, the scientific method. I mean, that's pretty lame, but it's descriptive. All right, here's how it works. First, you make an observation. Then, you cook up a theory, or basically you get an idea, and then you work on it until you get a hypothesis, and you work on it. Ultimately, you get a theory, and then you make it up right out of your own brain to explain that observation that you made back in number 1. And then you apply something called Occam's razor. All right? And then this is it. This is what Occam's razor is. This little sentence here. The simplest theory is the best theory. Okay? Occam's razor. Well, yeah. William of Occam lived from 1288 to 1348. That's a picture of him there. He was a Franciscan friar. And as you can see, like Franciscan friars, they would shave the top of their head. So I guess he probably used Occam's razor to shave the top of his head. I don't know why they did that. At any rate, so that's a stained glass picture. Occam was a town in Surrey, in England. And people didn't have last names then, so his name was William, and he happened to live in Occam, so he became William of Occam. That's their name, yeah. And that's a really, that's the Dark Ages, there was no real science back then, but the simplest theory is the best. It's brilliant, brilliant, man. Okay. Now, the fourth step is, if you've got a good theory, you can make predictions. Okay, so if you make more observations and your predictions prove to be true, you've got a good theory. And a bad theory is one that's refuted or shot down or disproved when it fails to make accurate predictions. All right? So what is this theory thing? How do we get? Okay, here's what it kind of looks like in the dictionary. You get this goofy word here with the upside down E and all these lines going. It's just a way to tell you, when you look at it in the book, that it's theory and not theory or something, so you know how to pronounce it. Okay, now in science, look at this. A theory is a set of ideas, and that's what, like I said, you see an observation, you get an idea about what is it you're seeing. You know, it's so well established by observations, that's lots of the number one back there, that it's essentially a fact. And after a while, you say, well, okay, I've observed and I've done the predictions, and it's made successful predictions again and again and again. It's like, okay, I guess after a while, it's, yep, I guess it's more or less a fact. It's capable of predicting the future, like predicting eclipses and things like that, and it's capable of being tested. It's very important. It has to be tested by making experiments, and it has to be capable of being falsified. Because I can tell you, oh, you know, I've got a unicorn in my garage. And you say, oh, great, I want to see this unicorn. And I say, oh, I'm sorry, I forgot to tell you, it's invisible. Okay, I'm going to fill the garage with smoke, and then I'll walk around, and where there is no smoke, there must be the thing there. There's smoke here, the smoke stops right there, that must be the unicorn. And I said, oh, I forgot to tell you, the unicorn is the size of a proton. Yeah, and so that's kind of the way that works. That's something that can't be falsified because you keep moving the goalposts, as it were. And being falsified is very important. Now, theory on the street, if you were to walk down onto the downtown mall here in Charlottesville, in common usage, theory can be basically a conjecture, an opinion, a speculation, or just a wild guess. And that's okay, but that's kind of what the same thing as synonymous with a hypothesis. Hypo meaning kind of like hovering above a thesis. It's not really there yet. It's not quite a theory yet, but it's getting there. And this conjectures, opinions, and speculations, and just downright guesses are the way science starts. But you have to work on it a while, because your other scientists, their job is to attack your idea and prove you wrong. Yeah, that's what it's all about. Well, here, I'll show you. In a flow chart. Yeah, you'll see more of these flow charts when you get into college. Okay, we start up here with this, and then you follow these arrows, and where the arrows come in, you don't go out that way. So you start here, you get an idea. You basically, in astronomy, you see something in the eyepiece, and you go, oh, that's interesting. I've never seen that before. In biology, you'd find a plant or something, and you'd see some chemical doing something strange in the plant. So you get an idea, and you go, I think what is happening there. All right. You come up with an idea. Then you perform an experiment to see if what your idea was true. And if the evidence from that experiment supports your idea, then you've created a theory. But if not, you've got a bad idea and you start over again with a new idea. Okay. Now sometimes you're the one who finds this evidence, and sometimes it's other scientists trying to shoot you down. You know, if they can shoot you down, that makes them feel better. So, well, that's how science works. Anyway, so if the evidence supports your idea, you've created a theory, and you use the theory to better understand the universe. But rather than quit then and go home, because yeah, you're only 27 now, and you've got kids in grade school, and a car payment, house payment, and so you don't want to retire yet, so you go back to work. The weekend's over after all, it's Monday, you got to go back to work. So you discover new evidence by going back to work, and you have to ask yourself, okay, can my theory back here, can it be modified to explain this new evidence? And if the answer is yes, you do the modification, you improve your theory, and you use the theory to better understand the universe around you. But if the answer is no, you have a revolution, and you go all the way back, and you start over again with a new idea.